You're watching North Penn Television on Channel 16.
Hello and welcome to Superintendent's Spotlight. I'm your host, Alan Elko. Superintendent's Spotlight will be a monthly program designed to highlight curriculum here in the North Penn School District. On today's program, we have Donna Brown, Supervisor of Science Education in the North Penn School District, and David Decker, Supervisor of Math Education in the North Penn School District. We'll begin our program with a discussion of the science program here in the district. I'd like to welcome you, Donna.
Thank you, Alan.
Donna, there have been many changes in science education in recent years, and you have been working on changing some of the goals in science education. Could you tell us about some of these changes?
Right. The main goal for science education these days is for children to really gain an appreciation about science as a way of knowing. It's part of a whole spectrum of learning. One of the things that children will be doing is constructing their own knowledge of the natural world. We expect children to be able to set up experiments, to make observations, to learn from them, to work just as scientists do.
How's that different than the way science has been taught?
If I remember back to my kind of learning, and you probably remember yours, it was open the textbook, page 47, we'll now start reading about plate tectonics, and we'll answer the questions at the end of the chapter. Not very exciting, not very much fun. It would be much more exciting for the teachers to come in and bring in some clay and ask students to actually construct a model of the Earth and some plates and how those plates might move. There's a lot of experiential knowledge involved with science education now, and it's much more exciting for children to learn and to process that information. We still want them to have the content. The content is extremely important, but we want children to be able to do process skills. We want them to be able to read a thermometer, construct a model, to make conclusions, and we want children to develop positive science attitudes. That has not always been the case.
When I was a student, my recollection of science was that by the time students reached high school, only a select few went on to take all of the science courses that were available. And typically those students were males and students who were interested in pursuing careers in science or engineering or medicine. I know that one of the goals of science today is to make science more accessible to all students. Tell us why that's important and what you're doing about that.
It goes back to the whole idea of science as a way of knowing. And we are improving in the field of having more and more students take more science courses, both males and females. We are also improving in the fact that even though students may take these courses, although they may not go on to careers in science, they have an appreciation for science courses and how they help students in decision making as adults. We are making science more accessible by providing students actually with materials to learn. It used to be textbook driven. Now we're more experience and experiment driven, just as scientists are. And we provide that in the schools with the forms of giving students materials to work with so that they can construct this kind of knowledge.
Well, you've told us how science is changing in our schools. Can you show us something that we can begin to translate what you're saying with and see firsthand how science is changing?
Certainly can, and perhaps one of the best ways to look at it would be to look at it sequentially from young children through older children. These are first graders, and these first graders are studying a unit called Weather and Me. And the title tells a lot. It tells that they are learning the content of weather. The me part tells that they are relating it to themselves. What these children are doing in this particular lesson today is setting up a series of cups with fabric on the top so that they might test how the water reacts to the fabric, whether it goes through the fabric or not. They have a chance to actually predict what they might think will happen before they do the experiment, very much like a scientist would set up a hypothesis. Then they actually perform the experiment, and then they gather and synthesize their observations. When I taught young children, I used to call this part guess and test. They like the guess part, but they like the test part even more. When they're through with the experiment, they will actually apply the knowledge they've gained. And in many cases, when these particular lessons were done in our schools here, children would be going home and testing all kinds of fabric in the house to find out what the reaction of water to that fabric was. So they brought it home in a very practical sense. What they've done here is set up the 4 different kinds of fabrics, and they're asked to pour 1 cupful of water very slowly over the top. This is a skill that's not easy for a first grader, but they manage it, and they gain the knowledge of something about the fabric by actually doing this test. You'll notice how very carefully this child pours the water over the fabric and notices that indeed, in this case, the water goes through. This is the first fabric they've tested. He's ready to add another one until someone says, nope, you're only supposed to add 1 cup here. That was a very expected result. It went right along with their predictions. But notice the next one. Notice the expression on the children's faces as a discrepant event or something really unexpected happens. The water is sitting on the top. Is this right? We used to spend a lot of time in science classes attempting to give the right answer. Now we know the answer is as right as the data you have. It's what you've learned about. We put it in a larger perspective, just as scientists do.
Now, will our students at this grade level begin to learn not only some of the concepts, but some of the terminology? Will they learn, for example, what water repellent means and what absorbency means?
Yes, they do. They learn the names of the fabrics like polyester and nylon, and these are large words for a first grader. And in fact, the teacher, as she picks up a jacket here and shows the children, she will explain to them how they can find out what fabric is in a jacket by reading the label. And they will learn to read labels not only in school, but at home. And this is a very important skill in today's marketplace, whether it's the clothes we wear or the foods we eat. They will also learn, for example, in this unit, some of the larger terms for weather, like cumulus clouds. There are some very important technical words here, but they've put it in a very practical, experimental context, and that makes all the difference for learning. I could have any first grader memorize what cumulus means, but until they actually make a cloud model, and they do, they understand much, much better by constructing the knowledge themselves. One of the other components of science education that we're really interested in is having kids be accountable. Again, just as scientists do. Scientists have to keep very detailed records, communicate with each other. And one of the things that wasn't stressed, I think, so much when you and I were learning science was the communications and the writing aspect. We thought that science was mostly numbers and number crunching, and we know it's a lot more than that. See these children actually working with a data sheet, and this is not the only one that they would do in this particular unit. They would be doing a lot more than this.
And so while our students aren't using a textbook, they're certainly being exposed to the written word and integrating the experimentation with the communication skills, both written and oral communication skills.
And it's also important that students be able to have a textbook as a reference, and we place great stress on reference material and on library work for students to gain even more content knowledge.
I only see a high degree of interest on the part of the students in this particular lesson. I suspect that all hands-on science, one of the goals of hands-on science is to hold the students' interests in science education.
And it does. It holds them a lot more, and it also creates an enthusiasm for learning. You'll notice here, 4th grade lesson. Now these students are obviously older in terms of their maturity, in terms of their skills. So they're going to be doing an experiment where they are dissecting flowers. They're learning the parts of the flowers. And this is something that we probably could have taught out of a textbook, but it's much more meaningful when the child actually dissects the flower, has to keep a journal, has to learn all the parts, has to diagram. There are many, many skills involved here. And we also expect students to be able to communicate what they've learned orally as well as in written form. And you will see that students in this particular lesson will have dissected the flower, but they will also have learned the parts and will have recorded all that information. And they share it with each other. One of the things that we like to model with students is the fact that scientists, and most people in industry, not just science, work in project teams. And the children have individual learning, but they also have some group learning going on here. And you'll see that they take great care with their observations.
You certainly see that as the youngsters move up in the grades, that for the fourth graders, the classroom is a little more quiet. The teacher can move around with the individual students and assist them. You see the developmental changes occurring with the youngsters in the way they're approaching learning, and therefore the response that the teacher can give to the learning.
Right. There are a lot of different classroom management skills involved in these types of experimentations because anytime children are involved in hands-on, there's a lot of disorder seemingly, but the teacher adds that structure and the children help the structure through because they're directly involved in the lesson.
We see that learning can be fun, and at the same time learning can be highly instructive.
Absolutely.
How do you account for the coordination of the developmental levels of the students with the way you're approaching science?
Well,
certainly at first grade you're approaching it differently than you might at the high school level.
Definitely, and part of that is in the expectations that we would have content-wise for children. For example, a wonderful unit that children love to learn is something called magnets and motors, but it's not something that's skill or developmentally appropriate for a first grader. It would be for a fifth or sixth grader, and in fact we'll be using that at sixth grade level. So there are some things that are very appropriate for a small child, but not so appropriate for older, and vice versa.
Is that not only because of the complexity of the concepts to be learned, but also the motor development of the youngster, that a first grader may not be able to manipulate the small parts of an electromagnetic motor, but an older student would have the manual dexterity to manipulate those parts?
Exactly. Those fine motor skills are something that have to develop over time. Even the task that you saw in that first grade lesson of putting the elastic band over the fabric, over the cup, is quite a task for a first grader. And certainly something like putting a small motor together is much more appropriate for an older child. And in fact, when we move to high school classes, we expect even more conceptually, because now students are able to move into the abstract and they are able to synthesize a lot more information. They are able to help each other learn. And you will see here a physics class in which a student is actually performing the experiment and providing a source of data to the rest of the students in the class. Students will have different roles throughout this lesson. There will be a student using a stopwatch to gather data. There will be other students processing the data. And there will be this student you see here actually performing the experiment and providing the data to the group. This again models the project team approach that scientists use to gather information. It also helps students in a very practical way. This is data gathering that we could certainly provide in a very simple way in the laboratory, or students could read about this data from a table. But it's more important that they actually create this data and use it and analyze it for themselves. And that's what they're doing in this particular class.
In summary, perhaps you could tell us what important changes you see occurring here in the North Penn School District in science education and why you see them as important.
I see that the kind of science education that we're doing here at North Penn, which is experiment-based in terms of students actually gathering their own information, gathering their own data, learning content in reference to all kinds of text and supportive materials, constructing their own knowledge, is a part of what I would consider national trends in science education. It's very much research-based, that this is the best way that children learn. Children learn by doing. Children learn by experiencing their natural world as much as we can provide them with the materials to do that. And in that, I think our final goal will be reached. I think our final goal of producing scientifically literate citizens, good decision makers, good problem solvers. We may not produce a great number of scientists, but we will produce people who are able to solve problems in their own lives and in their own careers. And that's more important because that's the most important part of education that we can provide for our children.
Donna, I'd like to thank you for coming on today's program, and I'd like to invite you back. There's a lot happening here in science education, and I know that our community is interested in seeing the changes that are occurring in science education. I think at a later date, when you have more to tell us about what's happening and give us a status report, I'd like you to come back on the program and show us where the continuing progress that we're making.
I'd be happy to come back and give you an update.
Thank you, Donna.
Thank you.
In the next segment of our program, we're going to join David Decker, Supervisor of Math Education for the school district.
It may not look like it, but you're watching the future of the Earth pass by, because many of these products are made from materials you've been recycling. But to keep recycling working, you need to buy products that say, made from recycled materials. For all those next in line, it would mean the world to them.
Welcome back to Superintendent Spotlight. Joining me for this segment of the program is Mr. David Decker, Supervisor of Math Education here in the North Penn School District. Welcome to Superintendent Spotlight, David.
Thank you, Alan.
David, we're going to put you on the spotlight. We're going to put math on the spotlight for a few minutes. Our nation has identified math as one of the key academic areas that our nation needs to attend to if our students are going to be successful now and in the 21st century. What are we doing as a school district, and what are math educators doing to meet that challenge?
Well, we appreciate this attention. We think it's about time that math be put in the spotlight, and we appreciate the fact that not only our community, but the nation's society as a whole is recognizing the importance of quantitative skills and math thinking skills that associate with science, but that they've become a predominant and a requirement for each one of our students to possess as they progress through our school system. So parents are insisting on it. Our leaders are insisting on it, and we recognize for our society to be competitive in the world market that we have to possess these kind of skills. So I think math educators are in a position to take on this responsibility and to deal with it in a first-hand manner.
Well, you used a few terms in that response that perhaps you can highlight for us and show us what you mean. You used quantitative skills, and you talked about problem solving and using math. How does that translate into the classroom?
It's an important aspect of math education that the computational skills that have characterized traditional mathematics are an adequate basis for understanding mathematics, but arithmetic is a small portion of what we expect of our students these days. Developing of an understanding of concepts is a place where we would like to begin this discussion, and we have a clip that I'd like you to see that characterizes some of the experiences that children have at the very beginning stage. This is a classroom of kindergarten students in which they're developing their quantitative skills, as you put it, but in a way their counting skills and their numerical relation skills at a very early age by rolling dice and manipulating objects that we use to help students develop the understanding of the relationship between sizes, shapes, and numbers. Here students are recording their results, and the teacher is outlining the progression that students would take when they reach their individual stations, and these students now are, this fellow is inspecting that one die very carefully, and students are working together then to record the numbers that are resulting when they roll their dice and create towers, as they call them, that correspond with the number that shows up on the dice. Now these kindergarten students, and this was recorded early on in the year, are at the stage when this is appropriate for their development. The use of the manipulative objects is one that doesn't end at the kindergarten level, and that we have integrated into our program at the appropriate developmental level throughout.
So in a way, what we're seeing here has some parallels to what Donna Brown talked to us about regarding science education, that at the early ages, our youngsters are learning mathematical principles with some very concrete manipulative materials, that they're not just using paper and pencil abstract methods for learning math, but actually doing mathematics.
Absolutely. The hands-on approach is really a necessity for students to develop the concepts of mathematics. And without that, the students are abstracting perhaps at too early of an age. One aspect of the students' experience that you're seeing here is the fact that they're recording their answers to the activity that they're involved with. And you'll see as we progress to some other classrooms today that students throughout our system are involving that recording and writing of their understanding of mathematical ideas to help develop their understanding. So it is not a circumstance that's unique to this kindergarten class. It just begins at this stage.
For some people, math has had a reputation of not being liked. And as I watch these kindergartners engaged in this math lesson, they certainly seem to be enjoying what they're doing. They seem to be very, very attentive to what they're doing. Are you finding that using manipulatives, using hands-on math concepts are increasing the level of student interest in mathematics?
Absolutely. The more actively involved students are in developing their learning, the better learning will be created as a result of that. Students in this classroom are involved in an activity where they develop the costs involved, the cost of accessories, the cost of borrowing money for the purchase of a car. So the teacher describes these kind of activities, and this is one of many in this classroom, as reality math. The reality portion takes the skills that they've developed in our standard curriculum and pushes it to the next level, where students are seeing a hands-on application, a content that associates very meaningfully to them of what it would cost to purchase a car. So Mr. Dugan's 5th grade classroom you see here is doing a computation and a worksheet that involve various aspects of that purchase. And so the topics are selected to help further develop their understanding and to keep their interest in the content of mathematics.
I also see in this segment, this clip, that our students are using calculators. Now, it's been said by some people that calculators are a crutch, and that as a result of using calculators, our students aren't learning basic math facts. How do you respond to that charge?
I would have that concern too as a parent and as a leader of math education if our students were using that as a crutch and to do the kind of exercises that we expect them to be able to do mentally and on paper. We, however, haven't selected the calculator to be integrated into our program in that manner. Our students are directed to use calculators when the topic and the activity corresponds to that. And in fact, the underlying premise in the use of calculators, not only in this 5th grade classroom, but throughout our school system, is that if it helps further develop the math concept at hand, then it's a legitimate choice to be used. Other than that, it really is not. So the judicious use of the calculator is an important part where the teacher is in control of its use. The teacher pulls out the calculator and hands them and distributes them to students if there's an activity that corresponds with developing their math ideas. And here in the circumstance of the reality math deal, it's very much of a case that the calculator can further enhance their understanding of the math concept at hand.
So when I was a 5th grader, I remember spending an awful lot of time being drilled on long division. You would tell me that our students are still mastering the basic math facts and then are able to use calculators in addition to learning many of our basic math facts.
wider view of math education involves that assumption that computational skills are there, basic number sense skills or math facts as you described it have been established, but as well students see a purpose for it and have experiences in extending it to the next level. The next level involves solving real problems, involved with complex problems, and to design ways in solving those sort of complicated tasks.
I think using a reality problem solving in the math program really addresses what some people have labeled as a criticism of math in general in this country, that students are able to sit down with a paper and pencil and do math facts, but then not be able to take those concepts and apply them to everyday living, where someone will say, well, they know how to add and subtract, but when they go into a store to make a purchase and make change, they aren't able to transfer what they learned in the classroom to what's expected of them in using math in everyday life. It seems like a reality-based problem-solving math addresses those types of concerns.
And curiously, the data that's collected from those national test results says precisely that students have the ability to do the basic computations, but they really fall down when it comes to taking it to the next step, to applying math in a real-life circumstance and interpreting a problem and then selecting the appropriate math skill to be able to solve that problem. And it's the case that we hope that circumstances like the emphasis on problem solving, whether it be through reality math or other activities that are going on in our school district, help to solve that circumstance for our students.
When you talk about calculators, I can relate to that as a parent of an 11th grader who's taking the new SATs. The SATs are, in the math section, they are permitting the use of calculators and in fact encouraging the use of calculators. Whether you know how to use a calculator or not, you still need to learn the basic math principles to be successful on the math portion of the SAT. If you don't know the basic principles, whether you know how to use a calculator or not, you're not going to be successful.
Our mathematics teachers would respond in agreement with that statement, that the distinction between students that have the capability of doing math is not whether they have a calculator in their hand or not, it's whether they know when is the appropriate time to use it and what are the underlying ideas that are being challenged there and whether they can respond to those. Now we have an additional class I'd like you to look at that is an Algebra 3 trig class of Mr. Russ Stewart's at the high school, where students are using a remarkable calculator called a graphing calculator that has an extensive array of mathematical components, but the one that we primarily use in this classroom is the ability of the calculator to create a coordinate graph by interpreting an analytical form of an equation with the push of a button. This skill is one that we expect of our students. However, we can take our students' understanding of the relationship between an equation and the graphical form of it to the next level through the use of this instrument. So we can progress students really to the next level if they understand their mathematics and have it developed with the use of this calculator. And so we're happy to see that this kind of calculator is helping our students progress considerably.
Now, earlier you talked about reality-based mathematics and using math to solve real-life problems. What kinds of real-life problems does a high school Algebra 3 trigonometry teacher bring into the math class that students can use every day?
The content of our courses certainly is a prime motivator in how we would select topics. And it's a challenge for every math teacher to select things that correspond to real problems. So an Algebra 3 trig class would discuss such circumstances, vibrations, or other motions that correspond to a trigonometric format. They may not be understandable by everyone in the general public. However, there are content that associate with each one of the contents of our courses, and it's important that we see that association whenever the opportunity exists.
So as you move through the grades into the higher level math skills in the high school, it becomes a more challenging prospect for our teachers to integrate the math concepts with day-to-day problem solving for the students.
Day-to-day problem solving is a challenge. However, the skills involved with the problem solving that have been developed, whether it's in first grade or in fifth grade in a reality math class, should translate to solving problems in a higher level math class where the content has progressed as well. The nature of the problem, the complexity of the problems has progressed.
As I see the students using calculators, whether they are in the lower grades or at the high school level, I have to wonder about other forms of technology being integrated into the math curriculum. And obviously, computers are an area that we're all interested in and would wonder, how are you beginning to use computer technology in math?
I've also selected an Algebra 2 class in response to that question that involves the use of the computers in which students are developing their understanding of algebraic topics in a circumstance in a computer room. And we'll let this tape roll a little bit, where you'll see students working on the computers with their partners to solve problems that are challenged by, that are offered by the computer. You can see that they're not simply working at the computer and making a stab at it, but they're actively involved in decision-making and discussion of solving the problems at hand.
Mm-hmm.
You can see students are recording the results, as we mentioned there earlier, is an important aspect of this for students to be able to not only write that one number answer that represents their answer to a given problem, but really their understanding of the ideas behind it. Mm-hmm. These students are working interactively with the computer and discussing. And so here's one way in which computer technology can help enhance the understanding of the mathematical concepts in an Algebra 2 class. As I mentioned previously, the underlying premise behind the use of any of these technologies is if they can help develop the math concept at hand, then they're a potential use in our classrooms. If not, however, if they become an end unto themselves, then they're not chosen.
Mm-hmm. As I look at the clip on that high school class there, I can't help but wonder, while the students are using computers, when I was in school, we were given graph paper and had to compute this paper and pencil method to come up with the answers. Our students are still expected to be able to find the answers without using computers, I would assume.
Certainly, just because I've picked two classes, one that uses a graphing calculator in one case and another Algebra 2 class that uses the technology, doesn't imply that that's the predominant instruction that's going on. And in fact, our students on a daily basis are being asked to solve some of those same problems that you and I solved 20 years ago and develop their algebraic skills, their trigonometric skills, their calculus skills, depending on the class in which they're enrolled, in that same sort of format. It is just that we have another option to help develop their understanding, and those are selected when appropriate.
Mm-hmm. Those of us of middle-aged generation, when we look at the clip of the high school students in Algebra 3 and Trig and Algebra 2, may think back to our own days taking those kinds of courses. They were elective courses in mathematics, and I would say from my own experience, courses that were predominantly taken by young men. I see in those clips that there are many, many young women taking those courses. What are you seeing in the higher level math courses? Are you seeing a change away from the tradition of math being a male-dominated academic discipline and more young women pursuing higher level math?
Well, we're happy to report that our students, both male and female, are having success at the higher levels in mathematics. One interesting aspect of our program is a statistic that perhaps you are not aware of, and that is that in our higher level math classes, the female population outnumbers the male population at every one of our advanced courses, which tends to say that we've been developing student skills no matter whether they be male or female in every one of these courses. Mm-hmm. And so we have some of our top performing students in our mathematics program are either female or male.
Certainly a large percentage of our students are going on to higher education, and therefore they're taking Algebra 2, Algebra 3, and trigonometry, calculus. But we also have students who are not interested in pursuing higher education. They're students who are going to enter the world of work, students who may be what we would traditionally call the general track, and students who are attending our North Montco AVTS. You've made some changes in secondary mathematics for students who are not going on to higher education. You've eliminated the basic education and general math components. What are you doing in mathematics for those students?
Well, we're happy to report that there's a school-wide change going on, and there's an emphasis on the applied format, and the courses that we've instituted in the place of what courses that were formerly described as general math are now called applied math. Now, this applied math format is one in which true life applications are selected over the more abstract format, and that students progress by the hands-on approach throughout their mathematical career, and that correspond to vocational aspirations and meaningful math activities for their understanding. We're looking forward to the application of these courses for all of our students beginning next year in 9th grade, and see that as being a challenge for our program and for many of those students involved to be able to be dealing with problems really presented at a much higher level, and that we're optimistic about that change for our system.
If I can summarize, what you've shown us here are kindergartners who are using manipulatives to learn math concepts. You showed us some 5th graders who are learning a reality-based math in which they took the concept of a car and the acquisition of that car to learn math concepts. Mm-hmm. You also showed us how various tools today are being used in mathematics, namely the calculator and the computer. Is there anything else that we need to know in terms of changes in math education?
Well, one other aspect of math education I think that summarizes all of these things and extends it a next step is the emphasis these days on what we call problem solving in mathematics. Problem solving includes the ability to take a problem, and some describe that as the only purpose behind math education, is to have students involved with the solving of problems, successful solving of problems. Some of the other aspects of problem solving would include the recognition of patterns, the ability to solve logical circumstances, and a wider range of math education. And students in this classroom are involved in developing their understanding of logical relationships by identifying the similarities and differences between geometrical shapes. Here the teacher and the classroom are separating the objects and organizing them, and now the students are moving towards separating those objects and then being directed to solve certain problems that involve their analysis of the similarities and differences between the shapes, the sizes, and the colors of those. We call this problem solving, and at the level at which these students are operating in the beginning of 2nd grade, it's appropriate for them to be discovering those kind of relationships. Here students work together in analyzing their response to a given set of questions that the teacher is directing. Although this is the beginning stage of development in being able to develop these logical problem-solving skills, it's one that is an emphasis of ours throughout our mathematical program. So the wider look in math education involves an emphasis on this problem-solving, on being able to see the mathematical connections between reality circumstance and the textbook learning or the skills learning that we do, and as well to be able to think mathematically. And that, if anything, represents a summary of some of the content and some of the emphasis in our program these days.
I'm sure that many parents, as they look at this program, have experiences in math when they were in school, that math might be different today than it was when they were in school. As they sit down and they help their 5th grader with their homework, or attempt to look and see what their high school student is doing in mathematics, they see some big changes. How would you characterize math education from when you were in school 25 years ago with where math education is today?
I think the math education of 20 years ago was more based on rote memorization and responses that were predictable. I think students now are being challenged to have those kind of skills, but in addition take them the next step, to be able to think independently and apply their reasoning and those processing skills to solve more challenging problems than probably we had the opportunity to experience in our former math education.
Do you feel that our students today are better prepared in mathematics than we were when we graduated from high school?
I'm sure that that's the case.
David, earlier you saw the segment in which I invited Donna Brown to talk about science education here in the North Penn School District. Oftentimes science and math go hand in hand, whether it's in measurement or computation or problem solving. In what ways are you working with the science staff here in the school district to integrate math and science education?
Science is a study that certainly has a quantitative base, so there's a natural marriage between the contents of mathematics and science. We have the obligation, and I think we're recognizing that we need to work together to develop some of the same skills in our students. Mrs. Brown mentioned the need to solve problems, to work in partnerships to solve problems, and to be able to think and reason. Notice that those are some of the same themes that we are now emphasizing within the math program. So there's a natural relationship between the two content areas that I think can be successful as we develop both of our programs.
David, I'd like to thank you for being a part of Superintendent Spotlight today. And I'd like to thank you for joining us on the first episode of Superintendent Spotlight. We'll be airing this program again in 1 month with a new topic to talk about here in the North Penn School District. Thank you.